Thank you so much for joining. In this session, I would like to give you an overview about key mathematical formulas that we use for valuation purposes. It's quite straightforward. There are a few formulas you may be familiar with and a few formulas that may be new. However, we use them when we value stocks or also when we value debt. Yeah, so I give you an overview about the key ones, and then many times when the cash flow pattern becomes more complicated, for sure, then we use spreadsheets or financial calculators. Good, we talked about the first part in one of the earlier sessions. It's single cash flows. So number one, when we talk about single cash flows and we want to move money through time, then basically our present value cash equals, or present value here equals our cash flow in year one divided by 1 plus our discount rate. Yeah, so if you have one cash flow pattern 5 divided 1 plus 10%, then you would know what 5 would be in present value terms. We can also do the exercise in the other way. We can say Cn equals C0, or in this case present value times 1 plus R, and then we see that's our future value. So here future value C0, cash flow in year 0 or present value, and then we move money through time. Yeah, so whatever this number is, 4 point something here, 4.xx. If we do the same here, 4.xx times 1 plus 10%, we would derive at 5. Yeah, single cash flow formula, and we talked about this here. This is your R, 10%, in this case your discount factor. Here it would also be 10%, but it is your compounding factor because you compound it going forward. And then what you do, future value higher, present value lower, to move single cash flows through time. If we talk about multiple cash flows, second scenario, we need to think about, do they stop somewhere or do they go indefinitely? If they go indefinitely, for example here, we start here and we say, okay, the cash flow 5 goes on forever, then we call this perpetuity. Means it never ends. For perpetuity, there are two ways. Again, if we want to calculate our present value or our cash flow in year 0, then our present value equals C1 divided by R. Yeah, and here C1, very important in this formula, the cash flow needs to be the same. Cannot be 5 in year 1, 7, 8, 5, 3, 4, needs to be 5. Then we can use a formula. If we have 5, 10%, 50. Yeah, so if we 5, and then as you can see, or as you may know, the more we go in the future, the less valuable this amount is in today's value terms. Yeah, so this is 50. It's called perpetuity. This one is called ordinary perpetuity, and then we have another one which is called growing perpetuity, which is exactly the same. The only difference here is that we assume it's not 5. Your cash flow here is growing at a constant rate, for example 2%. Then what we would do is 10% minus 2% and so on. This is called growing perpetuity, which would be 5 divided by 8%. So as you can see, the denominator gets smaller, so the number is higher than 50 because we assume the cash flows are growing. Yeah, so this is called perpetuity formula. Very important, cash flow remains the same, does not change, and what we assume is the cash flow goes on forever. We could also use the same formula starting here, not in year 1 but in year 3. What we would then do is we would calculate with the same formula, would calculate the present value. Here we would discount the entire green circle. Then we would have our present value terms in year 2, and then we would need to use our single cash flow formula, discount with the power of 2 to have our present value 0. So we can do the same. The only concern or things we need to be aware of when we use perpetuity formulas needs to be indefinitely. Then the third one, and this is the last part, is called annuities. The formula looks a bit different. Present value again, cash flow payment divided by R. 1, this is 1 divided, oh sorry, let's go back. 1 minus 1 divided 1 plus R to the power of n. Power of n, very important because it depends on how far you go. Yeah, I do 2 examples. This is again the ordinary, and then we have the equivalent PV equals C, cash flow or payment, could also use payment, divided R minus G, similar to what we did before. 1 minus 1 plus G divided 1 plus R to the power of n. Yeah, and this is growing annuity. Yeah, so that's the formula we are using. Again, if we have a growth rate of 2%, we assume those cash flows are growing at a rate of 2%. Other than that, they stay consistent. And then the main part here is very important. Here we assume the cash flows, they don't go on until indefinitely. For example, they start here and then they end here. 1, 2, 3, 4, 5 for 5 years. Then we would use n equals 5. R is the same as 10%. C is 5. G in this example 2%. R is 10%. And so on. Yeah, so 3 different formulas. The first set is for single cash flows. If we want to move single cash flows in time backwards or forward, we use the single formula. R is our discount or compound factor. When we want to discount cash flows that are paid indefinitely, we use our perpetuity formula. And then the last part is our annuity formula, which is expressed like here. Yeah, hope you find this useful. Basic things As said, if the cash flows become more complicated, or if you have cash flows that are, for example, here, if you have a cash flow that is 0 in year 4, you can't do it. You need to use annuity here, present value, then you can start again here, do perpetuity formula, discounted year 4, discount back, and then you can add them together. Yeah, hope you find this useful. As we go, I will do another video where we can go through some examples in detail, but just to give you an overview how the formulas work and what difference exists. Thank you so much for listening. See you later. Bye bye.